in match problem 3, rather than the definition of continuity, we want to use a theorem that was established and the general properties of continuity that we established to determine the intervals of continuity for each of these functions. So part A, it turns out, is actually an incredibly simple example. In this case, as long as we are able to recognize that this is a polynomial function, we establish that polynomial functions are always continuous. So this function is continuous on the interval from negative infinity to infinity. So we can plug in any value for x, that function will be continuous at that point. In part B, now we're dealing with a rational function. So according to what we've already established, this will be continuous as long as the denominator is not equal to 0. So in this case, our denominator will be equal to 0. If either x equals -1 or x equals +4. So our function is continuous except at -1 and at 4. So our function is continuous from negative infinity to -1, and we have an open interval because at -1 the function is discontinuous. We can use that intersection symbol, and we continue right on the other side with -1. So even though we're saying -1 and -1, we have this split here, the rounded parentheses indicating that at that point itself, the function is discontinuous. So it's continuous again from -1 to 4, and then again from 4 to positive infinity. So we have essentially an interval from negative infinity to infinity, but we have these essentially, these intersection symbols representing those breaks in those intervals. In part C, what we're dealing with is a radical function. We have the square root of x minus 4. So anytime we have a radical function, what we want to actually do is consider that interior function. So in this case, we're taking the square root of x minus 4. X minus 4 is a polynomial, so that function is continuous everywhere. But since this is an even index, even though we don't write that, where that's a square root, we have to consider where x minus 4 is non-negative. So we need to consider x minus 4 greater than or equal to 0. So that means x has to be greater than or equal to 4. So our function is continuous, in this case from the close bracket 4 to positive infinity. So again, all we need is this interior portion to be non-negative, since it's an even root, and since that's a polynomial, that's continuous everywhere, so there are no other values that we have to worry about. In part D, again, we have a radical problem. What we have to consider is x cubed plus 1. That's a polynomial function, so again, that's continuous everywhere. And we're taking the third root, so we have an odd root, so we don't have to worry about x cubed plus 1 being non-negative. So this function is going to be continuous on negative infinity to positive infinity.